Okay, the quiz is now too late to submit. I don't think I have to go over too much of it because you sort of either knew what to do or you didn't. Okay, so this is the way it should look like, and you should do something exactly like this on the test. If you do anything else, I may not accept it, but there's a reason why. X is along the top from -3 to 3. Y is along vertically 3 on the top and -3 on the bottom. And the reason for that is very specific because on the XY coordinate system, -3, 3 is up here, right? 3, -3 is over here. 3, 3 is here. -3, -3 is here, right? It wasn't that hard to come up with a pattern. I mean, after a while, you could have noticed, hey, it's just either adding one or subtracting one, and you just fill it all out. Okay? Then what's happening is you take these 49 numbers, put them all here. So essentially, you're really saying 6, 5, 4, 3, 2, 1, 0, right? Down here, 6, 5, 4, 3, 2, 1, 0. Down here, 0, -1, -2, -3, -4, -5, -6, and so on. Maybe I should use both pens. Along the bottom, you would say 0, -1, -2. If you watch both of my pens, -3, -4, -5, -6. Okay, then you should have one line. It's right up here. You should be able to tell from the lines, right? The way this is aiming, it's going to go to that one. That's going to aim, so you should get a straight line here. And then something below and something above. Okay, now, theoretically, I didn't say this before, but theoretically, no two solution curves ever touch. Okay, the reason for that, obviously, is if you came over and touched here, remember, you should be able to trace backwards. If you trace backwards, right, and you say, well, do you go to that one or that one? So very, very technically, no two will end up touching. I didn't say that to you ahead of time, so I let it go for this one, but I might not let it go for the test on Thursday. Okay, so that's pretty much it. The problem's finished. I'll dig a little bit deeper. What is the equation of this line right here? Okay, the slope is 1, clearly, over 1 up 1. The y-intercept is 1. Y equals x plus 1, right? Let's actually check it out. We had y prime equals y minus x, supposedly. Okay. So y equals x plus 1. What's the derivative of x plus 1? 1. What is y minus x? Well, y is x plus 1. 1. So show and tell. Y equals x plus 1 is definitely a solution of this differential equation, as you can see. Okay. I figured out the derivative, it was 1. I figured out y minus x, it's also 1. Okay, so this is a solution curve. Okay, we don't know how to get these other ones yet. Okay, in fact, we never will in our course. You'd have to take a course in differential equations to get all the rest. Okay. All right, that's that. The other thing I wanted to mention is I may start this even as early as Thursday, even though I know you're focusing on the test. I send you over the weekend a link to something called mathbits.com, okay, with a specific polar graph paper. Okay, so you'll need that for the next exam, and all your polar graphs are going to be this very specific one. I will not accept any others. For uniformity's sake, I want everybody to have the same piece of paper. Okay, I will mention some things about this. I know it's a little bit unfortunate because I might be lecturing on some of this on Thursday, and I know Thursday's a test, but I can just give you some highlights of this. Okay, these are every 15 degrees, and you can kind of tell because this is 0 and that's 90, right? So 0, 90, 1, 2, 3, 4, 5, 6. 90 divided by 6 is 15 degrees. So if this is 0 degrees, that's 15, 30, 45, 60, 75, 90, all the way around. And if you count, there are 14 concentric circles, okay, with the same center. Concentric means same center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so there are 14 circles. Okay, again, you must use this graph paper for uniformity's sake. Okay, and so you might have some other polar graph paper. I'm not going to accept it. You have to have this one. I sent you, so check your Canvas announcements. All right, I sent that. And you can find it also on a place called mathbits.com. so that I see the same graph and the same calculations for everybody. Okay, so the key things are these are 15 degrees and there are 14 circles. We're not going to do this today. I may get started with it on Thursday, but we'll see how it goes. Okay. All right, so that's that. So my aim is to do at least some of 10.2, maybe all of it. Okay. And then I'll let you have a question and answer session. Okay, so again, ground rules, our next exam is Thursday. First hour, I'll lecture, quote unquote, a while, and then stop questions and answers. We break and we take the test. Okay, that seemed to work quite well last time. Okay, so you say, how long do we have for the test? That's up to you. The only thing I'm promising you is 50 minutes. So the latest I will stop the first half would be what, 8:25. We've generally had a break before that. That way we start at 8:35, 8:35 and 9:25. The last time we started like around 8, and so you had almost an hour and a half, and that was quite better. Okay, so again, just like before, you submit this stuff. Okay, so if you want to turn it in early, you may turn it in early. Okay, anytime Thursday would be fine. Okay, so Thursday I'll lecture a while, 10.2 or maybe 10.3. When I stop, question and answers. Okay, the latest that will be is 8:25. But if nobody has any questions, then we can stop earlier, take a break, and then start the test. And once again, for the test, we'll break as usual. I will submit through Canvas announcements the exam, but I also project it if it's better for you to project it. So you have two ways. I'll project it and you can take a picture on your cell phone, or I'll send it through Canvas announcements. Okay, and you've had 2 test notes, so you know how it works. You must show your camera during the exam, so show me your camera, but mute yourselves. If you have a question during the test, send it through the chat. And then you have until 9:25. If we start earlier, like 8 something, I'll still give you until 9:25. But if you finish early, you can leave early. Okay, so at 9:25, that's a usual stopping time. I will stop the class and say, you know, goodbye and whatever. And then you have 5 minutes to get your cell phone and take a picture of your answers, or if you have a scanner, like cam scanner or something like that, submit that. So I'm giving you until 9:30 to submit the test, and then you have until 10 o'clock to submit the homework. But again, if you want to submit the homework earlier, you may. Okay, there's a 70% rule on the homework, as you know. So if I don't get any homework, or at least 70% of the homework, I don't grade your test. It counts as a 0. Yeah, and the coverage is 8.1, 8.2, 9.1, 9.2, 9.3. Nothing that I'm covering up to now, but I've already done 10.1, and I'll probably do 10.2. At least finish 10.2 by Thursday. Maybe sneak in some of 10.3. Okay, but 10.3 is on polar graphs. I might start it. You can, you know, casually take notes or look at the video later, but your focus should be on the test this coming Thursday. Okay. All right. So I'll get started with 10.2 right now. All right. So 10.2, it's calculus with parametric curves. Okay. So think back to 10.1. Problems like this, right? We have x as a function of t, y is a function of t. Okay. So we made a table sometimes, right? Make up a table, t, x, and y. X is a function of t. So I can plug in t, figure out x. Y is a function of t. I can plug in t, figure out y. Then when I'm all done, I just plot x and y. Now, I want to be able to find derivatives on this. And by derivatives, we mean the usual dy dx, rate of change of y with respect to x. Okay, so how do we do that now? Okay, so I'm on page 649, it looks like. All right, so how do I find dy dx? Well, you might recall from Calc 1, the chain rule. One of the variations of the chain rule is like this. dy dt can be thought of as dy dx times dx dt. Okay, and it kind of looks like you can cancel out the dx's, right? If you divide both sides by dx dt, it looks like this. Okay, so dy dx is dy dt divided by dx dt, provided that the denominator dx dt is not 0. Okay, and you can put this on your next formula sheet if you want. Okay, and if you kind of think about it, it's almost like this. Okay, you have dy dx, right? Then you just quote unquote divide top and bottom by dt, and then it looks like that. Okay, so to find dy dx, you have y as a function of t, x as a function of t. Just take dy dt divided by dx dt. And yeah, it kind of looks like you can cancel the dt's, so you have dy dx. For the second derivative, so this seems kind of intuitive. You know, if you agree with that canceling the dt's game, it's not quite as obvious for the second derivative. Second derivative, okay, I always say d squared y over dx squared. It means the second derivative. I don't have any convention on how to say that, except that's the way it looks like. So I'll say d squared y over dx squared, but keep in mind you're not necessarily squaring anything. Well, it means d dx of dy dx. I'm taking the derivative of dy dx. Okay, so now the justification I can give you is, okay, so you have d of dy dx on top and dx in the bottom. So d dy dx is that, and that. The bottom is dx. Now, quote unquote, divide top and bottom again by dt. So that dt and that dt got added in. Okay, I'm not sure if I can get this with my hands, but so sort of same game. That's the derivative of dy dx with respect to x, sort of, right? That's the same as this. d dx of dy dx. So there it is, d dx of dy dx. Again, quote unquote, divide top and bottom by dt. So that's how you find the second derivative. Okay, now that looks kind of scary, but it's actually not as bad as you might think. First of all, this dx dt, you already got that over here. So you just copy whatever you had here over here. So let's say this came out to be, I don't know, 3t minus 10. Copy that over here. The top is you just take the derivative of dy dx. So the answer that you got over here, just take the derivative with respect to t. These things are only going to involve t. Okay, so when you do this, you only see t or whatever the variable happens to be, maybe theta. And likewise over here, you take the derivative and there's only theta. Okay, I'll show you that when we get to it. Okay, there's one other formula that I need to show you involving arc length. That was the problems at the end. So at the very end, you had something like 41, 43, 45. They involve arc length. Okay, so arc length, we had radical 1 plus dy dx squared dx, right? Or dx dy squared dy, right? Well, if you do a little bit of finagling around with this, okay, they snuck in here a dy dt. It's almost like divide top and bottom by dt. And this dx, put a dt there and a dt there. Then they snuck that dx inside. Okay, so you can convince yourself of that algebra. I won't go through it, but this is what it essentially comes out to be. Okay, you put an extra dt there. That dx goes inside as a dx squared. And if you divide by dt the right way, it now looks like this. Okay, so for arc length, so we have this formula that you have on this coming test. When you have parametric equations, square root of dx dt squared plus dy dt squared dt. And if you stop and think about it, that kind of looks more like the Pythagorean theorem, right? If you take any one of these pieces, these all look like hypotenuse of something, right? Where you have a delta x and a delta y, hypotenuse. So this is delta x squared plus delta y squared equals delta s squared, little change in arc length. Okay, and if you take the square root, okay, this is delta x over, well, delta x squared and delta y squared. In the limit, it's dx and dy. And then you quote unquote divide inside and outside by dt. Okay, so this is radical dx dt squared plus dy dt squared dt. And again, you can put that on your next formula sheet. Well, they got it over here also. Let's find arc length. All right, so now I'll get started with some of this. Okay, so 10.2. 1 to 19, 25, 41, 43, 45. These last ones are arc length. There weren't that many of them. Okay, so find dy dx and so on. Okay. Okay, so x is t sine of t, y is t squared plus t. Find dy dx. Okay. Side note, there's no easy way to eliminate the t. You might say, can I just have y as a function of x? Have fun. It's not going to be very easy to do that. Okay. But we don't need to. So by formula, it's dy dt divided by dx dt. So dy dt is 2t plus 1. Dx dt looks like a product rule. First times derivative of the second, t cosine t, plus second function, sine of t, times derivative of the first, which is just 1. So there he is, dy dx. Okay, big difference for this dy dx is it doesn't have any y or x, it has t. So in order to find a derivative at any point, you have to plug in what the t value is. Okay. Which happens to be the idea behind problem 3. And 5, and again, I hasten to add, it's my 3 and 5. Okay, so find the equation of the tangent to the curve at the point corresponding to the given value of the parameter. Okay, and we already know, you know, and I know our problems may not match, but you're still learning this stuff. Okay, x equals 1 plus 4t minus t squared, y equals 2 minus t cubed at t equals 1. So find the equation of the tangent line. Okay, so we know what that's about. Find the slope. They don't give me the point, but I can figure out the point. I plug in 1. Plug in 1 here and here. So x is 1 plus 4 minus 1, which is 4. Y equals, plug in 1 here, 2 minus 1 cubed. 2 minus 1 is 1. So the ordered pair is 4, 1. Now I find the derivative, dy dx. So by this formula, it's dy dt divided by dx dt. So dy dt is negative 3t squared. Dx dt is 4 minus 2t. Plug in t equals 1. Put a 1 there and a 1 there. So negative 3 over 4 minus 2, which is 2. So negative 3 halves, that's my slope. Okay, plug it into point slope form. Y minus y1 equals m times x minus x1. So y minus 1 equals negative 3 halves times x minus 4. And for equation of a tangent line, you may leave it just like that. That's okay. You can just stop right there. Okay. The problem's finished, but what's interesting is that we don't really have a hold of y versus x or x versus y. We only have weird parametric equations, and yet we can come up with the equation of the tangent line. So we can get the equation of the tangent line better than we can write y as a function of x or x as a function of y. In fact, we may not even be able to do that. Okay. Okay, number 7, again, I should say my number 7. Find the equation of a tangent line to the curve by 2 methods without eliminating the parameter, t. And part B, first by eliminating the parameter. So get rid of the t. Okay, so for number 7, I think this number 7 is the same as the books. X equals 1 plus ln t, y equals t squared plus 2. So you can do this without doing the parametric equation stuff. Okay, you'd have to either get x in terms of y or y in terms of x. I'll show you that later. Okay, first I have to figure out what t is equal to. Okay, now I can plug in 1 right there for x, 3 right there for y. If I put 3 right here though, right, when I solve, because there's a t squared, I need a plus or minus. I don't want a plus or minus. So I'm going to solve for t over here instead. So plug in the 1, 1 goes here, 1 is x. 1 is equal to 1 plus natural log of t. Subtract 1, 0 equals natural log of t. How do I get rid of ln? Exponentiate. E to the 0, e to the ln t, these cancel out. So t is equal to 1. So that clinches it. And if I plug in 1 here, I do get 3. Okay, again, notice if I plug in 3 here, I would get plus or minus 1 for t. I don't want plus or minus, I just want one value. Okay, so that's why it's good to pick the function where there's only going to be one possible answer. So I know t is 1. Okay, so dy dx, dy dt divided by dx dt. So dy dt is 2t. Dx dt is 1 over t. Okay, I don't like the way that looks, so I multiply top and bottom by t. So that cancels out 2t squared. Okay, now I plug in t equals 1. dy dx is 2. That's my slope. So point slope. Y minus y1 equals m times x minus x1. Okay, so that's part A. Okay, before I go into part B, notice the difference between this problem and this one. Here they give me the t, which is what I need. Here they don't give me the t, I have to figure it out. So there's one more hurdle that I have to jump, so to speak. Okay, they give me the point, then I have to figure out the t. Why do I need the t? Because I got to plug in the t, right? The expression for the derivative only involves t, it doesn't involve x and y. Now here, if they give me the t, I'm not worried about that. I can always plug in to find the x or the y, right? Okay. Once they give me the t, you plug in here to find x, you plug in here to find the y. No big deal. So usually it's easier if they give you the t. If they already give you the t, you can just plug in to find x and y. But if they give you the ordered pair, the point, you might have to do some extra math to figure out what the t is. All right, part B, how do you eliminate the parameter? I need an equation that involves only x and y. So I have to somehow get rid of t one way or the other. Okay, again, if I solve for t here, there's a plus or minus. So I don't want to do that. So let me solve for t here. So x equals 1 plus natural log of t. Subtract 1. X minus 1 is equal to ln of t. How do I get rid of ln? Exponentiate. So t is equal to e to the x minus 1. Okay. Now, I plug that in to here. Y is t squared plus 2. But now I know t is e to the x minus 1. So here's t, right? T squared plus 2. So t squared plus 2. But I now know that t is equal to e to the x minus 1. Okay, and clean this up. So I multiply these exponents, right? So y as a function of x is e to the 2x minus 2 plus 2. And there we go. Okay, so Calc 1 problem. Find the equation of the tangent line. So y prime, the derivative of this thing, is e to the 2x minus 2 times the derivative of the exponent, which is 2. And of course, the derivative of 2 is 0. Okay. Now I want y prime of 1 because the x coordinate was 1. So plug in 1. 2 minus 2 is 0. So 2 e to the 0 is 2 times 1, or 2. Slope is 2. And I get the same answer. So the ordered pair was 1, 3. Y minus y1, y minus 3 equals m times x minus 1. And that's the same thing as I got over here. So I get the same answer either way, as you can see. Okay. Then let's see, what else I want to show you. Show you problem number 9 here. By the way, again, skip anything that says the graphing calculator icon. Okay, 9, or again, I should say my number 9. X equals 6 times of t, y equals t squared plus t. I'm at the point 0, 0. Okay, so what's the t? Well, if I solve here, 0 is t times t plus 1. So t is either 0 or t is negative 1. But if I put in negative 1 here, 6 times the sign of negative 1 isn't going to be 0. Okay, so negative 1 is not a possibility. It has to be 0. Check over here. 6 sine of 0 is 0. So t equals 0. All right, so dy dx is dy dt, 2t plus 1, divided by dx dt, 6 cosine t. Now I plug in 0. So the top is 1. The bottom is 6 cosine of 0. Cosine of 0 is 1. So 1/6. Slope is 1/6. It goes through the origin. So it's just y equals 1/6 x. Okay. Now, let's see, some second derivative problems. Find dy dx and d squared y over dx squared. So for the second derivative, I have to use the second derivative formula, right? Which was this guy. Okay, so I'll show you how that works now. And then after that, it says, when is the curve concave up? So think back to Calc 1. Concave up means second derivative was positive, right? So I take the second derivative expression and I find out when is it the expression positive. That would be concave up. Okay. Okay, so 11. Again, anytime I say a number, it's my 11 or whatever. It may match yours, it may not. This one, it actually does seem to match, but sometimes it does, sometimes it doesn't matter. All right, so what is dy dx? dy dt divided by dx dt. So 2t plus 1 divided by 2t. I can make that look nicer if I actually divide out. So 2t divided by 2t is 1. And 1 over 2t is the same as 1/2 t to the negative 1. Now, d squared y over dx squared, by formula, it's the derivative with respect to t of dy dx divided by dx dt. Again, it looks scary, but it isn't really. Okay, dx dt is just a copy of what you did over here, right? I already found dx dt, 2t, so there it is. So that is just going to get copied over there. Here, the symbols look scary, but just take dy dx, there it is. And this means differentiate with respect to t. That's what you should do, because the expression involves a t. Doesn't have any y, doesn't have any x. Differentiate with respect to t. So take the derivative of that. So that's not that bad. That's going to be negative 1/2 t to the negative 2. Okay, that 2 can drop down with that 2. Okay, I'm not sure if I taught you that trick before. But when you have a fraction like that, negative 1 over 2, that 2 can slide down with that 2 and becomes a 4. Okay, one way you can convince yourself of that is to multiply top and bottom by 2. If I multiplied 2 there, that's gone. And multiply that by 2, 2 times 2 is 4. Okay, so you have a fraction like this on top. You can just slide down over here. T to the negative 2 means t squared in the bottom. So I have a grand total of t cubed. So negative 1 over 4 t cubed. That's my second derivative. And it asks, when is the graph concave up? It really means, when is this thing positive? Okay, well, negative 1/4 is already negative. So I have to look at t cubed. In order for this whole thing to be positive, t cubed better be negative, which means t is negative. Okay, so concave up when t is less than 0. Okay. And yeah, I'll show you again my 15. X equals 2 sine of t, y equals 3 cosine of t. T is between 0 and 2 pi. And that doesn't seem to match what we have, but anyway, again, we're still learning the material, so to speak. Okay, dy dx, dy dt divided by dx dt. So the derivative of 3 cosine t is negative 3 sine t. Dx dt, derivative of 2 sine t, 2 cosine t, which is negative 3 halves tangent t. Okay, d squared y over dx squared, second derivative. The bottom is dx dt. We just did that. 2 cosine t. There it is. What about the top? I take the derivative of dy dx with respect to t. So negative 3 halves secant squared of t. Okay, same thing. 2 can come down, negative 3 over 4. Cosine on the bottom means secant on the top. So I have a grand total of secant cubed. All right, so concave up means this second derivative is greater than 0. I have negative 3/4. So that means this whole thing has to be negative. Secant cubed is negative. That means secant is negative. Secant is negative means the reciprocal, cosine, is also negative. Okay? If a number is positive, its reciprocal is positive, right? Like 7 1/7. And if a number is negative, like negative 3 over 2, the reciprocal, negative 2 over 3, is still negative. So if secant is negative, cosine is also negative. Where is the cosine negative? Quadrants 2 and 3. I don't know if you've ever seen this before, ASTC, all students take calculus, which is not a true statement, of course, but that's supposed to be the memory trick back in trig. Maybe your trig teacher taught you this, all students take calculus. What does that mean? That means between sine, cosine, and tangent, it tells you in the 4 quadrants which ones are positive. Okay, first quadrant, they're all positive. Second quadrant, only the sine is positive, which means cosine and tangent are negative. T stands for tangent. Tangent is positive, which means sine and cosine are negative. And C stands for cosine. Cosine is positive, which means sine and tangent are positive. That's supposed to be a memory trick. If you had to memorize it, which I'm not making you. There's other memory tricks. I've heard of ACTS, A-C-T-S, but you're going this way, A-C-T-S. I've also heard of forecast. Forecast means you start at quadrant 4 and you go C-A-S-T. So, you know, take your pick. So all students take calculus, or that's not even what, if you just want one word, ACTS, but you're going this way, A-C-T-S, or forecast, quadrant 4, C-A-S-T. But anyway, so where is the cosine negative? Quadrants 2 and 3. So T is between pi over 2 and 3 pi over 2. Okay, then let's see. It says something about horizontal and vertical tangent. Horizontal or vertical tangent. Let's go back to this. We've talked before about a horizontal tangent. Horizontal tangent means derivative is equal to 0, right? I have a fraction. When is a fraction equal to 0? When the numerator is 0, but the denominator is not 0. Okay, so horizontal tangent means dy dt is 0 and dx dt is not equal to 0. Okay, it actually turns out, even if this came out to be 0, you still might have a horizontal tangent. It's a little bit trickier. Then you'd have to do L'Hopital's rule from Calc 1, but hopefully we won't have to worry about that. Vertical tangent. Vertical tangent means dx dt is 0, because if you divide by 0, the expression is undefined, right? So that gives you a vertical tangent. So vertical tangent means dx dt is 0 and dy dt is not equal to 0. Okay. So I'll show you something like that. So 17, which seems to match my book also. So dy dx, dy dt divided by dx dt. So 2t divided by 2t minus 3. Okay, horizontal tangent, set the top equal to 0. That gives me t equals 0. Okay, and by the way, is the denominator 0 when I plug in 0? No, so we're good. Okay. It asks for a point, so I just plug in 0 here and 0 here. That gives me 0, comma, -3. Horizontal tangent. That's all. Vertical tangent. Set the denominator equal to 0. 2t minus 3 equals 0. T is equal to 3/2. Okay. And a quick double check, we have to see that dy dt isn't 0. If I plug in 3 over 2, I don't get 0 on the top, so we're good.
Hey, sorry to disturb you, Professor.
Sorry?
That should be t cubed minus 3t.
T cubed minus 3t.
That's how it is in the book.
Okay, you're right. Unless it was t squared in my earlier version. Okay, so I guess it doesn't match. So again, this is 17 star. So it may not match. Or maybe I had bad eyesight, but I'll go with this anyway. Okay, so plug in 3 over 2. Not as nice. 3 over 2 here, 3 over 2 here. 3 over 2 squared minus 3 times 3 over 2. That's 9/4 minus 9 over 2, which is negative 9 over 4. Okay, and y is 3 over 2. 3 over 2 squared minus 3. 9/4 minus 3, which is 12/4, negative 3/4. So negative 9/4, negative 3/4 is what I'm going with over there. Okay. All right, so that is that. And let's see. I think I was going to show you one problem at the end. Right, so the problems at the end, which were arc length, 41, 43, 45. So I'll show you 45, and I think it matches this time. Never mind about graphing the curve. Don't graph it. Graphing calculator. Find the length. X equals e to the t cosine t, y is e to the t sine t, t between 0 and pi. Yes, that matches mine. Okay, so you have 3 problems involving that, 41, 43, 45. I'll just show you one of those. So that's where I use this guy. Square root of the x dt squared plus the y dt squared dt. All right, so dx dt, product rule. First times derivative of the second, plus second cosine of t times e to the t. Okay, I cleaned it up to be e to the t parentheses cosine t minus sine t. dy dt, product rule. First function times the derivative of the second, derivative of sine t is cosine t, plus the second function, sine of t, times the derivative of the first, derivative of e to the t is e to the t. Again, factor out an e to the t, cosine t plus sine t. Now, I'm supposed to square them. So dx dt squared, I square this. So e to the t squared is e to the 2t, and then I have cosine t minus sine t squared. dy dt squared means I square this thing, e to the 2t cosine t plus sine t squared. So the arc length is the integral from 0 to pi of radical, all of this stuff. It looks pretty bad, but it actually comes out nice. So e to the 2t cosine t minus sine t squared. That's dx dt squared by formula. And then dy dt squared, e to the 2t cosine t plus sine t squared. Now, I'm going to factor out the e to the 2t, right? There's an e to the 2t here and here. So it's e to the 2t parentheses all that. And then the square root of e to the 2t is e to the t. So I just have e to the t left over. Okay, square this. Cosine squared t minus 2ab minus 2 cosine t sine t plus sine squared t plus square this guy. E to the 2t is already gone. Cosine squared t plus 2ab is 2 cosine t sine t plus sine squared of t. Okay. These two cancel out. Cosine squared t plus sine squared of t, 1. Another cosine squared t plus sine squared of t, another 1. So I have the square root of 1 plus 1, which is 2. That's a constant, so that comes outside. So I have square root of 2, integral from 0 to pi of e to the t dt. And now that's very easy. So the integral of e to the t is itself, e to the t, so radical 2, e to the t. Okay, plug in pi, e to the pi, plug in 0, you get 1. So the arc length is radical 2 times e to the pi minus 1. Okay. All right, so that's it for that. That is, let me see, what else was I supposed to do there? I do have 25, and let me see if I actually want to do that though. Because if it doesn't match what the 8th edition have, I might want to just skip it. Let me take a look. 25. Yeah, okay. It does match. So I guess I will do it. Okay, show that the curve x equals cosine t, y equals sine t, cosine t has 2 tangents at 0, 0. And find the equations, sketch the curve. Okay, so how do I do that? Okay, I'm at 0, 0, it says. Okay, so if I look over here, if I want this to be 0, cosine of what angle is 0? Well, pi over 2 and 3 pi over 2. So this is a unit circle at 90 degrees and 270 degrees. The cosine is 0. The x coordinate is 0. Okay, and I double check if I plug in over here, it also works. If I plug in pi over 2 here or 3 pi over 2, I get 0. So I have t equals pi over 2 or 3 pi over 2. So I'm plugging in both of those. Okay, so dy dx, dy dt divided by dx dt. Let me do the bottom first because that's easier. What's the derivative of cosine negative sine t? Top's a little bit harder. Okay, dy dt, product rule. First times the derivative of the second, so sine t times negative sine t, plus the second, cosine t, times the derivative of the first, derivative of sine t is cosine t. So I rewrite that as cosine squared t minus sine squared t divided by negative sine t. Okay, so if I plug in t is pi over 2, plug in pi over 2 here and here and here. Sine of pi over 2 is 1, so the denominator is negative 1. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so it's 0 minus 1 squared divided by negative 1, so that comes out to be 1. At t equals 3 pi over 2, plug in 3 pi over 2. The sine of 3 pi over 2 is negative 1, so I have negative 1 on the bottom, which is a positive 1. Okay. Plug in 3 pi over 2 here, that's negative 1. But if we square it, it's 1. So the top is going to be negative 1. Negative 1 divided by 1 is negative 1. Okay, so my slopes through the origin are 1 and negative 1, which is what was asked for. So that gives me y equals x and y equals negative x. Okay. All right, and so that was that one. So again, looking at the original question, show that this curve has 2 tangents at the origin. Okay, so there were two different t's at pi over 2 and 3 pi over 2. Okay. And let me see, I have another one here, but do I want to actually do it? The question is it the same thing? Yes, it is the same. Okay. So 41 is another arc length problem. So x is 1 plus 3t squared, y equals 4 plus 2t cubed from 0 to 1. So I use the arc length formula. So dx dt, 6t. dy dt, 6t squared. By formula, I got to square them. dx dt squared, 36t squared. dy dt squared, 36t to the 4th. All right, so I add them up. Arc length is the integral from 0 to 1 of the square root of dx dt squared, there it is, plus dy dt squared. So 36t squared plus 36t to the 4th. Okay, I factored out a 36t squared radical 36t squared 1 plus t squared. So if I take this outside, it becomes 6t, which I'm going to choose to write like this. 6 is 3 times 2, right? So 3 here, 2t here. The reason why I'm going to do that is because I'm going to do a substitution. The derivative of 1 plus t squared is 2t, right? So I'll do my substitution. So u equals 1 plus t squared, du equals 2t dt. Change the limits. When t is 0, u is 1 plus 0 is 1. Plug in t equals 1. 1 plus 1 is 2. So my new integral is going to go from 1 to 2. So I have 3 outside. Integral from 1 to 2 of radical 1 plus t squared is now radical u du. 2t dt is du. Okay. All right, so again, that's u to the 1/2. So 3, u to the 3/2 divided by 3/2 means times 2/3. These cancel out. So I have 2, plug in 2, 2 to the 3/2. Plug in 1, 1 to the 3/2. Well, 1 raised to anything is 1. And you know how this works, right? 2 to the 3/2, 2 radical 2 minus 1. So the answer is 2 times 2 radical 2 minus 1. And there we go. Okay. All right, and let me see. Yeah, I think that is all I was going to do there. Let me take a quick check with that. Yeah, that's it for that. I already have some problems to show you for review. So let me go ahead and show you those if I may. He was asked for 9.3, number 7. Okay, so 9.3, number 7, or my number 7 again. dy dt is equal to t over y e to the y plus t squared. So I split that up into y e to the y, e to the t squared. So ignore the y temporarily. E to the y plus t squared is e to the y, e to t squared, right? Okay, so we're doing separable equations. So multiply by y e to the y, that comes up here. Multiply by dt, it comes over here. So I have y e to the y equals t e to the negative t squared. I bring that upstairs. dt. Okay, so again, multiply by y e to the y, it comes over here. Multiply by dt, it comes over here. Bring that upstairs. Okay, so I call that I1 and I2. I1 looks like a typical integration by parts. Y e to the y. Okay, so u equals y, dv equals e to the y dy, du equals dy, v equals e to the y. So I1 is uv y e to the y minus the integral of v du. So that's e to the y dy. So I have y e to the y minus e to the y plus c1. Okay, so that's all of this. Then this one looks like a good regular substitution. The derivative of negative t squared is almost t. I got that over here now. So I2, integral of t e to negative t squared dt. So u equals negative t squared. Du equals negative 2t dt. So multiply by negative 2 inside, negative a half outside. So I2 is negative a half. Integral of e to the negative t squared is now e to the u. Negative 2t dt is du. So negative 1/2 e to the u plus c2. Change u back. So negative 1/2 e to negative t squared plus c2. So that's I2. I set it equal to I1. So y e to the y minus e to the y plus c1 is equal to blah, blah, blah plus c2. Just put the c2 and the c1 together and just put a plus c. So this is the answer. And you don't have to go any farther. You can stop. This is not possible to solve for y. If you have y mixed up with an exponential or y with a trig, you can't solve for it, which is good. So you can just stop there. Okay, then I'll show you one other 9.3. This was 9.2, but I showed you that last time. Okay, 9.3, number 15. And then I think I'll stop and then we'll break after that and let you ask questions. You can go ahead and put stuff in the chat if you wish, but I won't get to it until after the break. Okay, 15, again, it's my 15. X ln x equals y times 1 plus radical 3 plus y squared, y prime, and y of 1 is equal to 1. Okay. Yeah, that's the same as what we have here. Okay, well, we know that's dy dx. This already has all the y's, and there's a dx on the bottom, just multiply on this side. So it's like this, x ln x dx equals y times 1 plus radical 3y squared dy. So that's I2, that's I1. Okay, now we normally want to solve for y, so I'm going to call this one I1, this one is I2. Alternatively, you can switch it, move the left to the right and the right to the left, but it's the same thing, right? So I'm going to call this I1. If I distribute, it's y plus y radical 3 plus y squared, okay, which itself is two separate integrals. So I'm going to break this up into I3 and I4. That's an I3 there. Okay, so I have I1, I2, I3, and I4. So I1 is I3 plus I4. So I3 is pretty easy. Integral of y dy is 1/2 y squared plus c1. Okay, this one, integral of y radical 3 plus y squared, use substitution. U equals 3 plus y squared. Du equals 2y dy. So I need a 2 inside and a half outside. So 1/2 integral of radical u du. So that's 1/2 times 2/3 u to the 3/2 plus c2. Cancel here. So 1/3, change u back to what it was. 3 plus y squared to the 3/2 plus c2. Okay, so that's that. And then, yeah, I want to break because I don't want to hold you too long. But now to do I2, you integrate this by parts. And we did something like that before. Okay, so integrate this by parts to finish that one up. Okay. All right, but let's go ahead and take a break now. So let's see, it's about 8:10-ish. So let's start again about 20 after, roughly 8:20. And if there are problems you want me to do, go ahead and start putting it in the chat if you wish. But we'll break now, okay? So we'll start up again about 8:20. All right, folks, it's 20 after, so let's go ahead and start. Okay, check, let's see, Nathan, I got you. Rashawn, yes, we've had 2 quizzes for this exam since. Michael Vincent Rayo, I got you. Hao Zheng, I got you. And let's see, Mohammed Youssef, I got you. Right, so again, about the test, I think I was pretty much done with 10.2. I think I showed you enough of everything there. So the game plan for Thursday is I'll start some of 10.3. I'll lecture, quote unquote, a little on polar coordinates. I probably won't do any polar graphs yet, so just an introduction. So I'll lecture maybe half an hour tops, and then again, it'll be questions and answers. And if that, whenever that stops, as early as you wish, then we can just go ahead and start the test. So last time we started, I think even by 8 o'clock, so they gave you a good hour and a half, and that seemed to work well. And so we can do the same thing for this one. So I'm almost done today. So I'll finish up the one problem that I had, then I'll start taking questions. And when that stops, we're done. So go ahead and start putting stuff in the chat if you wish. So you got 9.3, number 3, 8.117, 8.221, 9.224. And that's as much as I see right now. Okay, so yeah, about starting early on Thursday, that's all up to you guys. I'm willing to start early, and that seemed to work well. So that means if you have any questions, ask me stuff today, so we can kind of get it over with as much as possible. Okay, so let's pick up where we were. You can keep typing stuff in the chat. I can't see the chat while I'm sharing the screen at the same time, though, so I won't be able to do that. Okay, but let me go back to where we were. We're still recording. Okay, so let me go back and share the screen. Okay, so I think we got down to here, I4. Okay, then we have I1 is I3 plus I4. So I1 is that plus that. Okay, so switch over to here. 1/2 y squared plus 1/3, 3 plus y squared to the 3/2 plus C3. I just call it C3 now, I suppose. I'm just checking what else I have to do here. Okay, then I2 was the integral of x ln x dx. And we said that one you should integrate by parts. Okay, and usually when you integrate by parts, you don't want to integrate ln. You'd rather differentiate ln. So that means let u be ln x, dv is x dx, like this, in other words. Okay. All right, du equals 1/x dx. Differentiate this side, integrate this side. V is x squared over 2. Right? Okay, so I2 is uv 1/2 x squared ln x, like that, minus the integral of v du. So minus the integral of 1/2 x squared times 1/x dx, like that. Okay, and it looks like you can cancel an x here. So you're basically integrating 1/2 x, is that right? Yeah, 1/2 x, right over there. Okay, so that's going to be 1/2 x squared ln x minus 1/2 x squared over 2 plus, okay, I got up to C4, so it's C5 now. Let's say C5. It doesn't matter how many C's you have. When you're all done, you're just going to put it all back together. So that's 1/2 x squared ln x minus 1/4 x squared plus C5. Okay, so finally I put together the left side and the right side. So way back over here, right? I have I1 and I2. So now I have 1/2 y squared plus 1/3, 3 plus y squared to the 3/2 power equals 1/2 x squared ln x minus 1/4 x squared plus c. Okay, again, now you put all the c's together, C1, C2, C3, C4, C5, it's all just one c now. Now, you can't easily solve for y here, but you can figure out the c because they told us that y of 1 was equal to 1. And we've seen problems like that before. So y of 1 equals 1. Plug in 1 for x, plug in 1 for y, figure out the c. So put a 1 there, 1/2. Put a 1 there. That's 1/3 of 3 plus 1 is 4. 4 to the 3/2. Square root of 4, 2. Cube it, 8. Put a 1 there. Ln of 1 is 0, so that's gone. Put a 1 there, negative 1/4 plus c. So that's 1/2 plus 8/3. Add 1/4 to both sides. So you have 1/2 plus 8/3 plus 1/4 is equal to c. Okay, common denominator is 12. Multiply by 6 over 6. Excuse me. Multiply by 4 over 4. Multiply by 3 over 3. So c is 41 over 12. Okay, just put that over here and you're done. So the final answer is 1/2 y squared plus 1/3 3 plus y squared to the 3/2 equals 1/2 x squared ln x minus 1/4 x squared plus 41 over 12, that weird thing over there. Okay. All right, so that's it for that. And now I will go to questions that people asked for. So let me mark those off. 9.3, number 3. Let me see what that's about. Number 3. X, y, y prime equals x squared plus 1. So x, y, dy, dx equals x squared plus 1. Divide by x and multiply by dx. So the x comes down here, the dx goes there. So I have y dy equals x squared plus 1 over x dx, right? Multiply by dx, it's over there. Divide by x, it's over there. Okay. So y dy equals x plus 1 over x dx. Now you can integrate. So y squared over 2 equals x squared over 2 plus ln absolute x plus c. Multiply both sides by 2. Y squared equals x squared plus 2 ln absolute x plus 2c. 2c is just c. And take the square root. So y is plus or minus the square root of x squared plus 2 ln absolute x plus c. And that's about all you can do for that one. Okay, 8.117. Y equals 1/4 x squared minus 1/2 ln x. X is going from 1 to 2. Find the exact length of the curve. So dy dx is 1/2 x minus 1/2 times 1 over x, which I'm going to write like that, or 1/2 x minus 1/2 x to the negative 1. Dy dx squared is 1/2 x minus 1/2 x to the negative 1 squared, which is 1/4 x squared minus 2ab, 2 times a half is a half. X times x to the negative 1 is x to the 0, which is 1, so it's just minus a half, plus 1/4 x to the negative 2. So 1 plus dy dx squared. If I add 1, the minus half just changes to plus a half. 1/4 x squared plus 1/2 plus 1/4 x to the negative 2. And if you think of where it came from, it's the same factorization as this, except that becomes a plus. So this is 1/2 x plus 1/2 x to the negative 1 quantity squared. Only difference was here. So instead of a minus b, it's a plus b. Okay, so that goes underneath the square root. So the arc length is the integral from 1 to 2 of the square root of that thing. Square root 1/2 x plus 1/2 x to the negative 1 squared dx. And when you have a square root of a square, you just take it off. So I got to go back up now. But I'm just integrating 1/2 x plus 1/2 x to the negative 1. Okay. So integral from 1 to 2 of 1/2 x plus 1/2 x to the negative 1 . Okay, let me factor out the half. X plus 1 over x dx, which is 1/2 x squared over 2 plus ln absolute value of x from 1 to 2. Okay, plug in 2. 4 divided by 2 is 2, plus ln absolute value of 2 is 2, minus plug in 1, 1/2 plus ln of 1 is 0, so I don't have to write it. So 1/2 of, let's see, 2 minus a half is 3/2 plus ln 2. Yeah, you can leave it like that, or if you want to distribute, you can. 3/4 plus 1/2 ln 2. You can get even fancier, but that's good enough for now. Okay, 8.221. Unless I'm looking at the wrong thing, this was not assigned. You didn't have to do these, I don't think. So I believe somebody asked for 8.221. I don't think we had to do that one. 8.2. Yeah, I completely changed the assignment. So 8.221 is not needed. 9.224. Okay, use Euler's method with step size 0.2 to estimate y of 0.6. Y of x is a solution of the initial value problem. Y prime equals cosine x plus y. Y of 0 equals 0. Okay, so let's write that down. Estimate y of 0.6. Delta x is 0.2. Okay, so I've got to get the calculator ready. Make sure in radian mode. So let me check, I'm in radian mode. So I start at 0, 0. Y prime is cosine of 0 plus 0, which is 1. M delta y equals m delta x, which is 1 times 0.2, which is 0.2. So my new point is 0.2, 0.2. The new x is the old x plus delta x, 0.2. The new y is the old y, 0 plus delta y. Okay, so I'll do it again. I have to do it 3 times total. How do I know it's 3 times? 0.2, 0.4, 0.6. Okay, so y prime is cosine of x plus y, 0.2 plus 0.2. So it's the cosine of 0.4. Cosine of 0.4, 0.92, 106, approximately. Delta y equals m delta x, 0.92106 times 0.2 times 0.2, 0.184212 roughly. So I'm at 0.4, 0.384212. And do it one more time. So y prime is cosine of x plus y. So cosine of 0.4 plus 0.384212. .707945. That leaves me at 0.6 comma, whatever that plus that is. .09216, roughly. Okay, so y of 0.6 is approximately 1.09. Now I can round off the final answer. Okay. All right, I think I've caught up with that round of the chat. So let me double check, stop the share and check if there's any more in the chat. Okay. Okay, 8.2, number 12. 9.221, 9.37, and can't see if there's any more. 21, 9.224, got that. 8.212, 9.2, 9.37, okay. So get that back. If anybody else has any questions, please bring it up. I mean, if you want to start the test earlier on Thursday, then ask me stuff tonight if possible. It's up to you. You don't have to. But if you ask a lot of questions on Thursday, then that's less time to do the test, right? Okay, so back to sharing the screen. Okay, let's see. 8.2, number 12 was asked for. Okay, let's see. Y equals x cubed over 6 plus 1 over 2x between 1/2 and 1. And you're spinning it about the x-axis. So if you spin it about the x-axis, you multiply by 2 pi y. Okay. Yeah, I remember this one didn't come out very nice. So y is 1/6x cubed plus 1/2 x to the negative 1. dy dx is 1/2 x squared minus 1/2 x to the negative 2. dy dx squared is 1/4 x to the 4th minus 2ab, the recurring theme. 2 times 1/2 is 1, times 1/2 is 1/2. X squared times x to the negative 2 is x to the 0, which is 1. So the middle term is just minus 1/2. Plus 1/4 x to the negative 4. If you add 1, that just changes to plus again. So we have a recurring theme here. And that factors back. You pretty much just copy what you have here, except change that to a plus. So 1/2 x squared plus 1/2 x to the negative 2. Okay, so that goes underneath the square root. All right, so the surface area is the integral from 1/2 to 1 of 2 pi y, 2 pi y since we're spinning about the x-axis, so I have to copy all this stuff. 1/6 x cubed plus 1/2 x to the negative 1, 2 pi y, and then square root of all this stuff. Dx. And of course, that just takes off the square root. So 2 pi comes out. So 1/6 x cubed plus 1/2 x to the negative 1. And that becomes square root of a square, 1/2 x squared plus 1/2 x to the negative 2 dx. So now it's just FOIL. It's going to take a while for me to finish this. Let me say either, etc. You can do the rest of this. It's just a little bit tedious, and you get some weird fractions. So if I clear the board, so to speak, and I have time left over, I'll come back to this. But this is now something you can all do. Just, that times that, that times that, that times that, that times that, and integrate. Okay, so that's as much of 8.212 as I want to do right now, unless there are no more questions after that. Okay, so that being the case, let me jump to the next one, 9.221. And I'll keep this ready just in case. 9.221. Use Euler's method with step size 0.5. So y prime equals y minus 2x. Y of 1 equals 0. Okay, they tell you to do it exactly 4 times, y1, y2, y3, y4. And this time we're not starting at 0, we're starting at 1. So it's going to go 1, 1.5, 2, 2.5, 3. So the language was step size 0.5, find y1, y2, y3, y4. In other words, do it 4 times. All right, so 1, 0, m, or y prime is m. So 0 minus 2 times 1, which is negative 2. Okay. Delta y equals m delta x, which is negative 2 times 0.5, which is negative 1. So I'm at 1.5 comma -1. Okay. I go down this time. Okay, so the new y prime m is y minus 2x, so -1 minus 2 times 1.5. -1 minus 3 is -4. So it looks like it's getting steeper negative. Delta y equals m delta x, which is -4 times 0.5, which is -2. 2 comma -3. Okay. What's the new x? It's the old x plus delta x. What's the new y? The old y plus delta y. Okay, 2 down, 2 to go. So the new slope is, again, y minus 2x. -3 minus 2 times 2, which is -7. What's the new x? It's the old x plus the delta x, 0.5. What's the new y? Oh, I'm sorry, I didn't figure out the delta y. Delta y is m delta x, which is -7 times 0.5, which is -3.5. I caught myself just because I didn't have a delta y yet. Okay, so now it's what, -6.5? Old y plus delta y, -3 plus a -3.5, -6.5. Okay, one more time. So the slope is y minus 2x. So y minus 2 times 2.5, and that's -11.5, I think. -6.5 minus 5, yeah. Delta y is m delta x, which is -11.5 times 0.5, which is what? -5.75. So now I'm at 3 comma -12.25. Okay. So yeah, if they want the actual y values, I guess, let's see, where are we? This would have been considered y1, y2, y3, and y4. So if I want to label them separately, just give the y values. So -1, y2 was -3, y3 was -6.5, and y4 was -12.25. Okay. Okay, 9.3, number 7. d theta dt, t secant theta over theta e to the t squared. Okay, so put all the thetas here. That goes up, that goes down. Theta d theta divided by secant theta equals t e to the negative t squared dt. Okay, multiplied by dt, it comes up. E to the t squared on the bottom is e to the negative t squared on top, multiplied by theta, divided by secant theta. And secant on the bottom means cosine on top. So theta cosine theta d theta equals t e to the negative t squared dt. Integrate, integrate. I1, I2. I1 looks like integration by parts. That one looks like a regular substitution. So I1 theta cosine theta. I1 theta cosine theta d theta. U equals theta. dV equals cosine theta d theta. du equals d theta. V equals sine theta. Differentiate here, integrate here. So I1 is uv theta sine theta minus the integral of v du, integral of sine theta d theta. The integral of sine is negative cosine, so I have negative negative. So theta sine theta plus cosine theta plus C1. And then I2, I have to do that thing. So I2 is integral of t e to negative t squared dt. The derivative of negative t squared is almost t. U equals negative t squared. Du equals negative 2t dt. So that means I need a negative 2 inside and a negative 1/2 outside. I2 is negative 1/2. Integral of e to the negative t squared is now e to the u. Negative 2t dt, negative 2t dt is du. So negative 1/2 e to the u plus c2. Change u back, negative t squared. So negative 1/2 e to the negative t squared plus c2. All right, then just set I1 equal to I2. So I1, where'd it go? All this stuff. So theta sine theta plus cosine theta plus C1 equals negative 1/2 e to the negative t squared plus c. You cannot solve this easily for theta. You can solve this for t. Well, yeah, you actually can, but normally you're supposed to solve for theta here, and we can't do that. So we're done with that one. Okay, I think I've caught up with the chat except for finishing 8.212. So let me go back and check what else was in the chat. Let's see, 221. Did that 9.3. Okay, I don't see anything else. Is there any specific way to draw the solution curves? Not really. I mean, if you have to draw something like this, which you more than likely will. Okay, I don't see anything else there, so that means I'll go ahead and finish up the one that I had. Go back to sharing the screen. Okay, so if you have something like this, which you can pretty much plan on for the exam, I'll give you something like this. Okay, so look for a straight line. There's a pretty obvious straight line that goes there. So I would say pick the straight line, one above and one below, like this to be an example. Okay, so the way the arrows are going, it's kind of going up, and the way these are going, it's coming down. Okay, so since I think I've caught up with the chat, let me go back and try to finish this one then. So back to number 12. So 1/2 to 1. Okay, 1/12 x to the 5th. 1/12 x. 1/2 times 1/2 is 1/4. 1/4 x. 1/4 x and minus 3. So let me double check. 1/12 x to the 5th, 1/12 x to the 1, 1/4 x to the 1, 1/4 x to the -3. Okay, when I get something that bad, I don't like all the fractions. So I will multiply inside by 12 and outside by 1/12. I can worry about the 1/12 later, just to make the inside look nice. So that becomes x to the 5th plus x plus 3x plus 3x to the -3rd. X to the 5th, x, 3x, so that's 4x. Okay, and I reached the bottom of my paper, so I'm going to go back up. So I'm going to rewrite it, except make that into a 4x. Okay. So 1/12 integral from 1/2 to 1, x to the 5th plus 4x plus 3x to the -3rd dx. So all I did was combine that. Okay. So 1/12 x to the 6th over 6 plus 4x squared over 2, right? Plus 3x to the -2 over -2 on 1/2 to 1. Okay, that really doesn't look nice at all. 1/12, 1/6 x to the 6 plus 2x squared. Okay, minus 3 over 2x squared. From 1/2 to 1. The 1/2 is really going to be not fun. Okay, plug in 1. 1/6 plus 2 minus 3/2. That's not so bad. The 1/2 is pretty bad. So 1/6 times 1/2 to the 6th is 1 over 64. Plus 2 times 1/2 squared is 1/4. Minus 3 over 2 times 1/4. Okay, now it's really just arithmetic, but real messy. So you cancel 2. So it's 3 divided by 1/2. 3 divided by 1/2 is 6. So 1/12, 1/6 plus 2 minus 3/2 minus 64 times 6, 1 over 384, minus 1/2, minus a minus, and we said this was 6, right? 3 divided by 1/2 plus 6. Okay, how much more do I want to go here? 2 minus 1.5 is 1/2. Minus 1/2 is 0. Cancel, cancel, cancel. Unless I made a mistake there. So 1/6 minus 1 over 386 plus 6. Oh boy. So 384 divided by 6 is 64. So it's not fun watching me do arithmetic, right? 64 times 384 times 384. 1/12 of 384. So what's this going to be? 6 times 384 plus 64 minus 1. 2367 over 384. And I don't know if that's reducible. Yes, you can take out a 3. 5, 11, 18. It's divisible by 9. $263 over 4 times 128. $263 over 512. Unless I messed up somewhere. That is 2 to the 9th power. You can't take a 2 out of that. Okay, so unless I goof somewhere, that's finally the answer to that one. Looks like. Okay. And yeah, we're still recording, so you can check the video back for this. Okay, let me check back here. Okay, and I think I've caught up. If I missed your question, please ask it again now. Otherwise, I think we're done. What time is it? It's a little bit past 9. Okay, so it's up to you. You can ask more questions, but if not, we'll stop. Okay, so Thursday, again, I'll lecture a little bit on polar coordinates, let you ask questions again. And then whenever we stop the questions, then we'll break 10 minutes and start the test. And you know what's involved. Okay, so anything else, please? Wait a moment, either unmute yourselves or put it in the chat. No? Okay, then we're done for the night, folks. All right, so have a good evening, and we'll see you Thursday for the test. I'll lecture a little while, and then we can take questions and answers and take the test. All right, good night, everybody. See you next time. Bye.
Bye, Mr. Hall.
Bye, Daniel. Mohammed, I do not have office hours tomorrow, unfortunately. You can maybe ask me a question. I can try to reply back, but it's not the same as office hours. Okay.